In this example, it says find the concentration of donor atoms in which the silicon is doped so that at temperature T equals 300 Kelvin, the concentration of electrons is twice as holes. It is known the value of Ni. So what formulas do we need at the beginning? First of all, we need the formula about the relationship about electrons and holes, that is Ni squared equals N times P. First, we know that this silicon is not intrinsic. It means that it is already doped. So we use this formula, and from the information we have, we can write that electrons, or N, it is twice as holes, so that means N equals 2 times P. If we substitute N here, we get Ni squared equals 2P squared, and from here we can find that P equals the square root of Ni squared over 2, and if we substitute the value of Ni, we can find that P equals 1.06 times 10 to the power of 10th per centimeter cube. And in the moment we find the value of P, we can find N as 2 times P, and we get 2.12 times 10 to the power of 10 per centimeter cube. We know the values of N and P. We only need the value of donor atoms. We can find that using the formula Na plus N equals Nd plus P. In the moment it says it's doped with the donor atoms, the Na goes to 0, and we can find that Nd equals N minus P, and if we substitute the values, we find that Nd equals 1.06 times 10 to the power of 10th per centimeter cube. So this is the value of those donor atoms from the information given above.